Also for the watchers of the online video, start from the very beginning. We're going to talk today about Ethereum and a short overview of what it is and a little bit of practice with the Ethereum code simulator so that we can also get a feel of what contracts are on the blockchain and a little bit of how it works. So I'll go to the next slide first. What is Ethereum? Well, it's a smart contract and decentralized application platform. And basically it means that it's a platform that you can run code on, but just like Bitcoin, it's decentralized. It uses a blockchain. And the difference, however, with Bitcoin is that it can do a lot more complex things. You can run code on the blockchain, and as it says in the Ethereum white paper, it's designed to be a foundation for innovation. So with Bitcoin, we have functionality that has been defined in advance. And there can be small improvements on it, but it's not open for the general public to start changing code around and start making that very dynamic. And so new innovations on Bitcoin have to be programmed outside of the Bitcoin protocol itself. With Ethereum, we're looking to change that. So some people would ask, why do we want Ethereum? Because we already have Bitcoin, we already have a myriad of interesting cryptocurrencies that all have their own interesting functions. So what's the use for Ethereum? Well, currently the cryptos that are there, which are more than 300 at this point, that have a reasonable market cap, have their own interesting and innovative functionalities. For example, Namecoin implements a decentralized DNS on top of a blockchain. But Ethereum can do so much more. And by being able to dynamically implement code, you can reintroduce all these concepts, but then on a single blockchain. So other cryptocurrencies are just too simple, and the setup is not complex enough to be able to do that. The same goes for Bitcoin. It has some scripting functionality, some options that you can script your own escrows, for example, on the blockchain. But that's not complex enough for what we want to do if we want to actually run code on a blockchain. So also the other blockchains don't have an advanced way to process data, which means that if you want to process data, you have to script that again outside of the current solutions that are there. Except maybe Namecoin, but also its data processing is quite limited to just DNS entries and spitting out IP data or key value data when queried. So how does Ethereum work? Well, of course, it's difficult to say that in a few sentences, but to provide a general overview, first of all, just like Bitcoin, it has a bootstrapping sequence. So it hooks into a network in a decentralized way, it finds its peers, and it creates the network by bootstrapping. So bootstrapping is a process by which you have a certain list of IP addresses or ID identifiers, and you go by those identifiers and you find your peers, after which you get lists of more peers, and in that way you can bootstrap into a network. Instead of saying we're paying each other with Satoshis, in Ethereum you have a unit called Ether. And the smallest unit of that, I believe, is the Wei. They have all these names for individual amounts of units and where you put the decimal point. So, but the main unit of Ethereum is Ether, just like the main unit of Bitcoin is a Bitcoin. And its smallest unit, in that case, is a Satoshi. It's a Turing-complete scripting language. So in Ethereum you can create contracts that can eventually even compile other contracts, in which you can re-implement a new, even maybe decentralized system. And it uses Merkle trees to reflect the state of a certain part in the blockchain, so that you can easily calculate the validity of a part of that blockchain. But beyond that, there's much more. if you want to dig deeper into the cryptographic aspects, you should revisit the white paper and certainly follow the blog. In this case, just like data coin, we have, and like Namecoin, we have persistent storage on the blockchain. So you can create a contract, you can program it, you can store it on the blockchain, and even data that is manipulated by that contract is stored on the blockchain of Ethereum as well. And this makes it possible to spread immutable contracts to a great number of people and have them run those contracts in a decentralized way. Well, when you execute a contract, that means when you run a contract, this costs a certain amount of ether. And why did we implement this? Because when you run a contract and you, for example, would like to abuse the Ethereum network, you could create a contract that creates an infinite loop, and it would just keep on using CPU cycles. So to make sure that doesn't happen, when a contract runs on the Ethereum blockchain, it costs a little bit of ether, and that means that running your program costs eventually value. The first 16 steps of a contract are essentially free, but after the 16 steps have passed, it starts costing ether. So an infinite loop might be allowed to loop 16 times, but after that it would cost you a lot of money to try and sabotage the network. So there are some basic design principles that Vitalik Buterin tried to keep to when he designed Ethereum. And one of them is simplicity. He wants to make sure that there's not a lot of features like other cryptocurrencies. For example, NXT, which claims to be the next cryptocurrency. It has a lot of features that are programmed into the NXT code base. But Ethereum tries to remain as simple as possible, because all these options, these extra ideas, should be able to be implemented by people that work to make contracts for Ethereum. Again, a foundation for innovation. Also, the design is attempted to be universal, so it should be very accessible, and the code should be easily readable. And the implementations in Ethereum should be very compatible to all kinds of ideas. Modularity, of course, is part of that, so that means you can click one contract onto another. You can actually create a combination of a whole lot of contracts that work together, that perhaps would even form a decentralized company with no people that necessarily need to operate it. The whole company works just by contracts that work together instead of human beings. Agility is also important. So the code base of Ethereum is designed to be simple, it's designed to be universal, but if mistakes or flaws are found, it should be very easy to change and make sure that Ethereum keeps running the way it does. However, that makes bug fixing easier. And in the end, Ethereum should be non-discriminative. So if somebody does want to try and create an Ethereum virus, or let's say an infinite loop, he or she should be able to do so. It comes at a cost, but it still is possible. So creating a little cost to running code doesn't provide much incentive for people to create sabotaged code. However, if they really want to, they still can. So in that way, it's non-discriminative.
Is it the code base, is that open source, or is it closed source?
It's open source.
It's open source. So you could copy it down if you would like to, and then you could start a Nether or a beta or whatever you like.
Yes, if you'd really want to, you could clone Ethereum code and start a new blockchain that can run code. Yeah. So where is Ethereum in the crypto sphere? This is a word I coined, so I'm not sure if it's actually a real word, but I call the cryptosphere, what I think is the cryptosphere is everything that has to do at this moment with the modern ideas of decentralized cryptography. And since we already have the word cryptocurrency, I thought it would be logical to just say, okay, we also have a word called cryptosphere, which shows the sphere in which these things are developed. Well, this overview has been made most probably by somebody who's kind of likes Ethereum because it's in the center of the graph. It's of course attempts to show its universality and its versatility, and how it's basically core to every idea that revolves around this. I don't know if that's true. Time will still have to prove if that's true or not. However, in this graph you can see a few interesting things about Ethereum that show its space compared to its place compared to other cryptocurrencies. So first of all, I could start this time on the outside before I started on the inside. But now I started on the outside, and we look at the idea of open transactions. That is a platform for creating automated financials, and it's not got a blockchain. It doesn't have a ledger, but it is good at calculating numbers and creating automations of financial processes. So it could very well be used in combination with cryptocurrencies, but it can also be used to keep an account of euros or assets in other ways without a blockchain. So that's what open transactions is. However, Ethereum does have a blockchain, and so it's inside the field of blockchain-based cryptocurrency. Inside the crypto ledger, we of course have the Bitcoin, and the Bitcoin has its is one of the first. It is the first cryptocurrency in this case with a crypto ledger, and it's got something that's called merged mining, in the sense that all the spin-offs of Bitcoin that also use SHA-256 as an algorithm can be used to do merged mining. So you can, when you're looking for Bitcoins with your hashing power, you can actually be looking for name coins at the same time, and it doesn't necessarily cost you extra hashing power. Bitcoin is also based on the idea of proof of work. So that means a system must prove it has done a certain amount of work before value is created. Before you can find a Bitcoin, you have to be crunching hashes for a long time until you find one of them in the cryptographic cloud of numbers. Same thing goes for Namecoin, Litecoin, Dogecoin. These Litecoin especially has a different algorithm called script instead of SHA-256. But this is all the same as Ethereum. So Ethereum has proof of work. However, Ethereum also has an idea called proof of stake. And one of the ideas here is that you can prove that you have a stake in a certain base of value. And in Ethereum that could be by issuing assets, but it's also built into Ethereum itself. So this stake will be distributed as soon as Ethereum is started, and people will have to invest in that to give it its initial value. At the same time, new ether can be forged or mined by proof of work as well.
Is that used by the contracts?
Proof of stake could be used in a contract situation, but then you would essentially be creating a new asset. So then, of course, you have a proof of stake system. I don't think proof of work would be very handy to use in a contract, because it would cost a lot of contract money, as it were, or ether.
So they chose proof of stake to avoid the quite costly solution of burning energy, to avoid using proof of work, because it's so energy inefficient.
Proof of work is good, but eventually it stops. So after let's say 20 million bitcoins have been mined, it's going to be extremely difficult to find the last ones.
Yeah.
And so to give Ethereum its longevity, they've created a proof of work, proof of stake hybrid. And this means that after proof of work starts living out its use, proof of stake can take over. And but also from the beginning already, proof of stake is being used. So to make sure that Ethereum doesn't have to create its value from just using proof of work, but can already create it from an initial distributing of the ether. This will also fund the Ethereum development, so that's probably why they made it up to do it that way. Well, of course, it has an independent blockchain. It's Turing complete, so that means it can run its own code that can recompile itself. Ripple could also do this, however, Ripple was a lot more centralized, and as we've seen in recent news, that can also have bad consequences. This designer also said it has to do with next generation smart contracts, and in this case proof of burn, like Counterparty uses, is not used. At least it says in this graph it's not part of that. However, if you would issue an asset in Ethereum, you could still use the idea of proof of burn to create value for that asset. So that's up to the innovators of the like the Ethereum coders of contracts. They can make a proof of burn situation.
So it's very interesting for pyro people.
Well, proof of burn is not much more than proving that you've sent cryptocurrency to an irretrievable address. So you send it to an address from which you cannot retrieve it. But if you take it in a literal sense, you could actually use proof of burn to, for example, say, burn euros, which in the Netherlands is against the law. So you could burn euros and film it, or have people watch and audit that, and then say, now I've burnt 100 euros, I'm going to create an Ethereum asset worth 100 euros, and you can sell that asset for that value.
Do you know the KLF? Does anybody here know the KLF? It was a 90s dance act, and they have a movie where they earned a lot of money with their dance music, and once they decided that they would burn 1 million British pounds, they said they really did it. There's footage of it, but I mean you can always question if they did, but I know that they were quite crazy, so I think they did really. But there was it's an often cited event when it's about burning money.
The proof of burn could be quite good if you cheated in the beginning and kept a lot yourself of the coins, and afterwards you want to change that and be fair again, and then you can do the proof of burn. Yeah.
Right.
In the case of Counterparty, proof of burn was used from the beginning. And because in the blockchain you can check if coins are actually burned, people could see that there was proof that 21 bitcoins were burned to create an initial value for Counterparty. Now some Bitcoin enthusiasts were not very happy because there's only a limited amount of bitcoins. What are you guys doing burning bitcoins? But okay, this is the way it was done, and it worked. So it was an interesting case. Well, what are practical applications with Ether? And I think we already have a little bit of an idea, but I'll just recap. Of course, we could make a decentralized exchange, for example, by programming a complex set of contracts that can accept certain assets or certain cryptocurrencies, perhaps even, and then repay those with other cryptocurrencies or Ether or other assets. Crypto stocks is a very good example. Right now, these are still often issued centralized. With Counterparty, it's already possible to issue a decentralized asset, so also a crypto stock, Mastercoin as well. And as we can see, all these new ideas are vying for first position. They are more or less doing a race against each other. Ethereum, however, is not yet live, and so these gaps are now filled in by things like Counterparty, Mastercoin, and ProtoShares. Something that could also be proto shares. Yeah,
it's the crypto share.
It's also a crypto share idea. Yes.
Isn't it kind of like colored coins? Proto shares?
No, proto shares was developed by Invictus Innovations, and just like MadeSafe, they want to redesign the internet.
A decentralized idea.
Yeah.
But are they completely open source? Because MadeSafe is
no, they're
open
not
source, but centralized or something. There is something hidden. I don't know exactly what. But
ProtoShares, as far as I know, is completely open source.
Oh, okay.
But
and also peer-to-peer, etc.
Yes, but there have been some hiccups at the start because of disagreements in the.
Yeah, because I heard something that they wanted to store 160 bytes with each Bitcoin transaction.
That was Counterparty.
Ah,
yeah.
Okay.
And they got in trouble with the counterpart with the Bitcoin developers.
Okay.
It seems to have been resolved more or less because Counterparty is functional. But Bitcoin developers wanted to make the amount of data you could store in a block a lot less, and that would mean Counterparty would be in trouble. But they've apparently either found a way around that, or they've come to terms with each other. So, well, derivatives, whether you think they are good or bad, they are possible to be implemented in Ethereum. And things like peer-to-peer lotteries are already being made. I saw recently that the Dogecoin Make It Rain app, which is a phone app to just make it rain money in a certain place, has already been implemented in Ethereum. It's also a very nice example to look at, so I could give you the web address of that later, so you can just, it's a nice YouTube film as well where that's all explained how it works. You can make reputation mechanisms like MemoryCoin did with its voting mechanism, but then in Ethereum, that you can vote on something. If you send a very tiny bit of Ether, everybody can get a fair vote. If you make the amount so small that it's basically worth only 1 cent or less, even your average homeless guy could come in and cast his vote, because it's possible for him to get at least that little bit of Ether. Or perhaps somebody will make it rain and give him the chance to vote and maybe become a rich man.
The local government, then they don't have to do the paperwork again. Yeah.
True. Yeah. So in short, you could do something called DAOs. The term's been switched, the letters have been switched, but basically it stands for Distributed Anonymous Organizations, and they can be implemented with
something
code.
like the board, for example.
Well, it's really far-fetched, but some enthusiasts would want to go that way. So this is a little code example. There are some people that were very proud of what Ethereum could do, and they said, look, with just a few lines of code, you can implement Namecoin, the decentralized DNS cryptocurrency. I'm not completely in agreement with that, because Namecoin does a little bit more than that. But yes, it's true that with a little bit of code, the basic functionality of Namecoin is already replicated. So in this case, you can see what it does. First of all, it checks, is there enough Ether coming in to run this contract? If there's not enough Ether, the contract won't finish running, and it's not good to end with an unfinished contract. So if there's enough Ether, the code continues. And there it checks. If the storage in question is already being used, and if it is, nothing happens. But if something new is being added, then the contract stores data. And in this case, it stores it in the storage array of the contract itself, because that's an important thing to mention. Ethereum contracts have a certain amount in which they can be stored, a certain amount of bytes. However, that same amount of bytes also stores the data of the contract itself. So to be safe, most programmers at this moment use the 1000th byte position of a contract to store the data, to make sure that there's a lot of space for the code. Because it would be a bad idea if your contract starts storing data over itself, thereby erasing its own functionality. So, well, here you see it stores the data, and it just takes the send key first.
When you make up the amount of storage, is it a RAM storage? I mean, is it like werkgeheugen, random access memory, or long-term storage, or is there no difference in this case?
Well, basically, a blockchain like Bitcoin's and also like Ethereum's is essentially a read-only blockchain.
Okay.
But it behaves like a random access blockchain in the sense that later on things can be amended or changed. An old contract could be invalidated and a new contract takes its place. Mm-hmm. And so in that way a contract can also change its own storage by writing to it as if it were a flash drive that can only be written once. But by using the space properly, and because the blockchain can grow and grow and grow, it can still act like random access memory. But that is expensive. So it's a good idea always to think out very carefully what you're going to store in the blockchain and why.
Yeah, because you have to make, when you design the program, you have to make a difference in long-term storage and random access. There is a difference.
Yeah.
Okay.
Let me just make sure that phone turns
Maybe a stupid question, but what did you study? What kind of programming did you study to start this?
Ethereum?
Yeah? To change the Python programming, COBOL, I don't know.
Well, this is a Lisp-like language.
Yeah.
But Ethereum can be programmed in many types of languages,
yeah.
because what it does, it compiles it down to bytecode.
Yeah.
And that's run on the blockchain. Compilers for that are being written right now. So there's, for example, a JavaScript-like compiler and a Lisp-like compiler. And those are being used already to create a test code that runs on the Ethereum test network.
Yeah.
And right now the Lisp-like language is pretty popular, so that's being used most. But for JavaScript bindings, the JavaScript variant is now also being used more and more. And, but that's all very new, so it's still in development.
What kind of solutions will it be for people who don't have access to code,
who don't know how to program?
Yes.
Well, there might be later on tool sets of small contracts that act as tools so that people can just click contracts together. Just an idea, for example. But you could probably make the contracts for the least amount of cost by being able to program them yourself, or by hiring somebody that can make those contracts for you.
But it's actually almost the same as JavaScript, eh? Like if Bitcoin is HTML, then this is JavaScript. So not a blank page, but something you can do. You can book your flight, or you can make a contract. Yeah.
Yeah. Okay. This is dynamic.
Ja.
Heel even.
Hij is bijna voor.